My name is David Sneider, and over the next 10 minutes, I'm going to tell you about what we've been building at Lit, a key management network that has a lot of implications as it relates to credentialing, reputation, and onboarding. So just to set the context, the way we see the world is that the era that we're living in, and if we're in this room, we're very much in this era, which is we are now moving from an era where people are consuming compute services rather than from companies, from fault-tolerant and programmable networks. Of course, blockchains are the main example of this, the money network. Then there's systems like IPFS, the data network, and what we are working on is a key network, and I'll tell you a little bit more about that. But why do we need a key network? And the main thing is that key management is one of the most complex and cumbersome parts of the whole operation here. And even if we think about the founding document of this space, the Bitcoin white paper and the preamble, basically the first sentence is, we need digital cash. And the second sentence is, digital signatures provide part of the solution. And then Satoshi goes on to explain proof of work as the solution to the Byzantine generals problem. So from our perspective, we really see taking the Web3 ideals of fault tolerance and making distributed systems and applying that to digital signatures as quite pivotal. And so just for the historical context, let's look at some of the individuals that enabled this type of technology. These are Adi Shamir, Andrew Yao, and Lisa Su. You may recognize Adi Shamir's name from Shamir's secret sharing scheme, basically one of the first people to start thinking about how to take a secret and divide it up into multiple parts. Andrew Yao was the first one to propose a solution to what's called the millionaires problem in the context of secure multi-party computation, basically a method for determining if two people have a certain amount of net worth, how can they prove that one has more net worth than the other without them revealing the amounts? And then Lisa Su is the current CEO of AMD. And I'll talk a little bit about that, why that's relevant, as I explain the way that Lit works. So functionally, there's three technologies at play in this key management network. One is MPC-TSS. How do you take key material and divide it up over a diverse set of operators where there's a threshold? In Lit's case, it's 30 node operators with a threshold of 20. And then all of that computation is performed inside of a special type of processor called secure encrypted virtualization, where each of these nodes essentially is running a black box that they can't get into, and they are attesting to the fact that the code that they are running, they're essentially attesting to the code that they are running inside of that encrypted virtualized environment. And then also in that environment, there's a JavaScript execution environment running. So one way to think about this work is what Ethereum did for databases by making them distributed and programmable and fault tolerant. The work that we're up to at Lit is to apply those same attributes to KMS, to key management systems. And so you can see in this graph, we'll cover some of these details here. But functionally, what we can do is the two underlying features of keys in general, which is to be able to encrypt things and sign things. There's a diverse set of node operators. The network is launching shortly. Here's the list of them. And so what developers get when they want to build on this system is the ability to generate wallets that are connected to things like multi-factor authentication, social auth, email, SMS. Developers can articulate application logic around when they want this distributed key to sign. Now, this distributed key can either represent a user, or what we've seen, especially relevant as it relates to credentialing, is folks using this distributed key as an automated issuer of credentials. So if we think about verifiable credentials, who signs that credential? A key needs to live somewhere for that. We've seen some really interesting products be built out where the distributed key is the issuer key, and then automated flows be built out that use both on-chain and off-chain data as the trigger to sign the credential or the reputation and to do the issuance. And then a lot of really exciting work has happened at the intersection of Ceramic and Lit regarding encryption. And the most simple example would be something like token gating, but this could be as complex or sophisticated as one wanted it to be, especially around selective disclosure and granting decryption rights. But functionally, the process here is Alice can encrypt some data client side, and it uses something called identity-based encryption, which is a fancy way to say conditional or rules-based encryption. When Alice does that encryption client side, she says, in order to decrypt this, this requires another signature. The signature that it requires is the signature from this distributed network lit. And then Alice also associates a set of rules and says, anybody who owns a CryptoPunk, for example, can decrypt this. When Bob shows up later, let's say that encrypted blob is stored on Ceramic. When Bob shows up later, he signs a message. He independently connects to the 30 lit nodes. Each of those nodes independently validate, does Bob meet the rules for decryption? So they do an RPC call, do the checking. And then the system from here works a lot like torrenting does, where Bob collects individual authorizations from 20 of these 30 nodes and puts together those authorizations. These are called signature shares in the world of MPC, client side, and they can use that signature to decrypt that data that Alice encrypted. And this is something that's really, really exciting in the world of user-owned data and selective disclosure, because we have client-side encryption, client-side decryption, with no party in the middle that was able to see that data. And so I've talked a little bit about how this works. The private credentialing is a really exciting use case to explore, as well as the automated methods for credential issuance. And then one thing I'm really excited to mention today as it relates to onboarding, we've seen a lot of teams use this product for building embedded wallets, wallets that work inside of Discord, wallets that work inside of Telegram. But there's a new product that we have been experimenting on and have the first few users that want to try this out. If this is something that you're interested in, you can go to this website, domainwallet.id. And the concept here is to leverage some property that every project has, which is a URL, like acme.com, and basically turn alice.acme.com into something that is a crypto domain, but essentially the next level of a crypto domain. In addition to being able to receive funds, because there's a routing contract similar to ENS, that crypto domain also has a distributed key associated with it. And essentially the way that we're thinking about the way onboarding could work in a really coherent UX in the future is the end user is essentially logging into their key or into their account, alice.game.gg, bob.dow.com, whatever it might be, and then that account name is a crypto domain, but it's also a wallet, can generate the signatures to sign into a dApp, to sign a message, to sign a transaction. And so this was a lightning talk, only had a couple minutes, tried to make sure that I went through as quickly as possible. But the essence of what we've been up to is to basically apply the core Web3 ideals to key management, and are just so excited to be a part of building the new web. You can find me on Twitter and email and everything if you'd like to keep talking. And I think maybe there's a couple moments for questions. Thanks for your attention.